Hi, my name's Titus. Hi. This is my boss here. He's all, yeah. So I'm a I was a software development engineer and test at 5 different companies before I joined my current company, Sauce Labs. What this means is I found 5 different ways to screw things up before I started doing what I'm doing. So a lot of the things that I talk about are coming from things I've done wrong, things that I've learned. This is why you don't want to do it this way or that way. And also just lots of conversations with some really smart people in the industry. And Simon. I'm also an open source developer. I started with Water and then started working with Selenium. So, Water's a test library in Ruby based on Selenium. And now I'm a senior solution architect at Sauce Labs, and that means I get to give talks like this to people, talk to our clients quite a bit about things they're doing well and not doing well, a lot of code reviews, trying to get into the specifics of how people can do better with test automation. So there are 2 transformational changes in the testing community in the past 20 years. The first one is manual to automated, and the second one is automated to observability. And Marcus is going to be talking about some of that tomorrow in the morning, so I'm going to just skip right past that for the purposes of this conversation, and he'll get to share all of that tomorrow. So, title of this talk is Valley of Success. This comes from the notion, especially in the ops world, of we have one right way to do things, we've structured things so there's no redundancy, and if you deviate from the right way to do things at all, you fall into a pit of failure. And so there are people that are thinking, how about if we create a system where it's really easy to succeed? And so when you fail, or so when you do something, you're going to fall into a pit of success instead of a pit of failure. And I'm thinking about this, and I'm like, well, it's not like it's a pit, you're either in a pit or you're out of a pit. Usually, you're trying to progress towards a goal, you're trying to progress in a certain direction, and you're constantly making decisions that will either help you succeed or make it easier to fail. And the goal with this idea is to try and do things that make it harder to fail. If you just focus on trying to be more successful with your automation, you'll often end up doing things that, not thinking about things down the road that will make things more difficult for you. The other reason I call this the Valley of Success is I do not like mountain climbing analogies. Testing is like this, testing is like that, testing is like climbing a mountain. Like, what does that mean? When you get to the top of the mountain, you're done testing? I want to think about this as you're continuing moving in a direction and you're constantly making choices that are going to help or hurt you. So I also like this framing rather than calling this, I used to call this presentation or presentations like this when I was working with clients as a best practices talk. And yes, I've done a lot of things and I know things that work better than others, but who am I to tell you what is best? I can tell you things that I have seen work to make it easier or harder. And so I've seen people make really ugly, complicated, horrendous code and processes work for them. I don't always understand how, but they make it work. But they shouldn't have had to put all of the time and energy and resources into that in order to get it to work. So I'm not going to say you can't do this, you have to do this. It's all going to be ideas for how you might think about changing one aspect of what you're doing. I get a lot of people with some of the things that I say, but this other way that you're saying not to do it, that totally works for me. I'm like, that's great. But usually processes and code are kind of a map of how an individual person thinks about something. And not everyone thinks about things the same way or works on things in a common fashion. Has everyone heard of a bus factor? It's the idea of how many people on your team can be hit by a bus before you can't continue working on the product. Often it's one. There's one person that understands it, and when they leave, everything starts failing. Everyone that's left looks at each other. Do you know how to fix this? No. Do you know how to fix this? And then so they scrap the whole thing and rewrite it in JavaScript, because that's just what you do these days. And then the other thing is I've had people say, no, but this is the thing that I always use, and it's great, and everyone should do the same thing. It's like, well, you learned one way of doing things, and you apply it everywhere, and you don't actually know it's the best because it's all you've ever done, and so you don't have perspective to say whether it's actually the best. Okay. Costs of automation. We have creation costs, execution costs, maintenance costs. Which of these is the most expensive? Maintenance costs. If 2 months down the road, if you're not spending more time maintaining your code than creating new tests, you are doing very well for yourselves. Vastly, vastly, vastly more expensive down the road for most people. And so we need to constantly be thinking when we're creating tests, how do we make them more maintainable? And when we're executing tests, we're not looking to optimize test time or test execution. We're looking to optimize maintainability, even if that might sometimes come at the expense of longer test runs. So when I'm talking about major transitions, what I'm saying is you can't just take the manual process. How many people here are manual testers right now? That's their primary role. Not a ton. Okay, how many people started manual testing before they did automation? All right, a lot more people. If you try and take what a human does and then just try and make a computer do that, you are not going to be successful with what you do. And a lot of, especially managers, think like that. I'm very comfortable when a human does things this way, and so I will only be comfortable if a computer does it the exact same way. And the problem with that is humans are good at things that computers are not good at, and vice versa. So what we're looking to do is to build the same confidence level with what computers are good at as you had with what doing things that humans were good at. And who here is not familiar with the test pyramid? Is there anyone here that has not seen a test pyramid before? I see a couple hands raised. The idea is, especially in a lot of legacy code and legacy managed systems, the developers don't write unit tests, and they knock out some ugly code and then send the results to some separate test team in a different continent and say, make sure I did everything right. The problem with that is that unit tests are much faster and more reliable than doing things in the browser. So the goal is to try and get the right side up pyramid where you have mostly unit tests, a lot of service layer or integration tests, and minimize the number of UI tests. I like to say that if you don't have to open a browser to test the functionality, please do not open a browser. So this means constantly thinking, is there a better way to do it than the way that is the most obvious to me as a manual tester? So one of the problems with creation costs is the signal-to-noise issue. If you have so many failures that it takes you too long to figure out what's actually wrong with your code, then you're not going to be able to find the actual real bugs that are causing a problem. Sorry for the graph here, but it looks kind of like this. When you're just starting out, you're trying to figure out how to get coverage. You're spending more time doing automation than you would be if you just did manual testing. Then you start building up your test suite. You're at a nice sweet spot where the number of tests you have are rock solid, they're all passing, you're getting a good signal back, and then you've got your manager saying, more coverage, more coverage, more coverage, and then so you implement a whole bunch more tests, and now you start seeing more failures and things. You're still able to keep up with it, but you're seeing failures constantly, and you're constantly every day coming in and trying to figure out the 10 tests that failed yesterday. Are they real failures? Is it a synchronization issue? What's going on? Unfortunately, what I way too often see are people that are way past that. 50% failure rate, 60% failure rate, 70% failure rate. At that point, I'm almost suggesting to teams that you might as well start over at that point. Most likely, you're not going to be able to just consider this all a sunk cost and get something that's stable. There are other ways to address it, but that might be the best at a certain point. So more is not always better. Constantly asking, is this test that I'm creating going to be more useful than the overhead and the benefits? It's okay to delete tests. I give you permission. Have your manager talk to me. There are a lot of tests that shouldn't be tested in the browser, and if you can test them in another way, it vastly increases the reliability. So the next thing is speed. The most important thing here is how quickly can you get feedback to the developers rather than focusing on giving feedback to yourself as a tester. And obviously these roles are kind of merging in a lot of places, but we way too often think about the tests that we've written as, like, we get emotionally attached to the tests. And so we're, in the morning, we're working on, like, oh, what test, oh, Johnny, you failed last night, like, let's put a Band-Aid on you and good luck tomorrow. We need to think of our test suites as a product that we're providing the developer team rapidly, so that they're not going home over the weekend and then coming back in the morning and like, what code did I write? I don't remember, there's a problem. Let me figure out what's going on. If we can get that fed back to them right away, that's the ideal. And that pretty much requires scaling. All right, so now on to maintenance costs. This is where we spend most of our time. There's essentially 4 possibilities for any feature that we're evaluating. Either that feature is working the way it's supposed to, or it's not. And the test we have to evaluate that feature is either passing or it's failing. If it's passing and the system's working, great, that's what we want. Probably the biggest issue is if we have a test that is passing even though the system is broken. This is where you have catastrophic failures because you think you're protected from problems and you're not. I think one of my favorite stories is from Marcus, who worked at a company where the entire system went down one night and the entire test suite ran. You come in the morning, 37 tests passed. That's a problem. You think you're protected from things that you're not. The most common place where people spend most of their time when they're using Selenium is when you have failing tests even though the system's working correctly. This usually comes from flakiness or brittleness. Sometimes it comes from real changes that the developers made that they didn't tell you about before you ran the tests. Flaky tests are, sometimes they're passing, sometimes they're failing. It's usually a synchronization issue. I'll talk about that later. Brittle tests means some minor change was made and the code that you wrote wasn't flexible enough to handle that minor change, so it started failing and it's never going to pass again. And then the fourth quadrant is you found a bug. And I can't tell you how many times in the Selenium IRC channel someone comes in and like, what's wrong with my test code? And we ask them questions, and after 10 minutes of working with them, we're like, oh, no, your system's broken. This is a good test finding a real problem. And they spend so much time in that lower left quadrant that they don't even realize that it's possible that they found a real bug. They just assume that they wrote a bad test. So addressing maintenance costs, 2 main ways of doing this: having good test practices and then having a good test framework. And I'll walk through all of these. So I don't really do TDD the way that people say to do TDD. When I'm thinking about writing a test, 1, I make sure that I want to actually open a browser to do it instead of some other way. Then I write the test itself before I do any implementation. What is it that we're actually needing to do? Then I write the implementation. Make sure it passes reliably. It doesn't do any good to put something into your repo that's going to start failing tomorrow. I've seen people run it 100 times and have it pass all 100 times before they actually accept it into their test repo. Then this is the important one: make sure it can fail. So this is kind of opposite of what TDD says to do. They say make it fail and then they make it pass. I want to think, how might this, what would happen for this test to give me the correct information that I need? I need to be able to break something or turn it off, make sure it fails, and then it can be a good test. And then it's good to get the code out, make it work, and then go back and make it better when you need. And I'll talk about that a little bit more. I don't think I have sound for this, so this video might... Yeah, we'll just get past that since I can barely hear it. So known states everywhere. This means your code needs to be deterministic. There shouldn't be a bunch of conditionals that can take you into weird places where you don't know where you're at. And I use anchor points for find a way to reliably get to the precondition that needs to be there for the rest of your test. And there are multiple ways to do that, but you need to make sure that it's a known state and that it's not going to vary from execution to execution. CI server. I have seen people try to run 100 tests on a very underpowered CI server. Not going to work. What you're testing against, if you've deployed to AWS or if you're running on your local staging environment, you need to make sure that it can handle 100 simultaneous tests run against it. I've had this issue at a former company where after trying to run 30 tests in parallel, everything starts getting weird timeouts. And I go to the DevOps, and I'm like, what's going on? He's like, oh, we got the cheapest AWS version we possibly could. I'm just like, that's not going to work for the testing that we need to do. So we fixed that. And then what you're testing on, and this is where a solution like Sauce Labs is great because we give you a blank system every single time you run a test. There's going to be no browser caching issues, no system issues. Everything is going to be a clean slate. So the point of this is think about it's not just your code that can be giving you failures, and you're still responsible for those failures. So scaling tests, this requires your test to be atomic, autonomous, and short. And I'll talk about those individually. Atomic tests. So every test has 3 pieces: an arrange, an act, and an assert. And the focus really needs to be on the action. I want to have atomic tests that this is the one thing that I'm testing, and if it fails, then I know what's wrong. And it might be okay to have multiple assertions on that action. The success message showed up, I'm seeing the thing properly displayed on the page, and it got added to a list. I'm okay with that. But the focus needs to be on the specific thing. Probably the biggest issue I see in maintainability is when you're writing tests and having them be imperative instead of declarative. And there's a lot of tools out there that encourage imperative test writing in frustrating ways. Imperative is essentially a recipe of step-by-step exactly what to do. Declarative is the big picture business model idea of this is what the product person wants to do. They don't care about if it's a drop-down or a checkbox. They just want the feature to work. Easier to see this with an example. This is Ruby. It's easy to read. Not as many words, but there's still a lot of words here in this imperative example. There shouldn't be. We're using the Selenium API directly in our test. We've got the driver object, the element object, specific methods on the element object. We are specifying data. We're specifying the URL, specific locator values. This is the recommended way of using a declarative approach. Everyone, regardless of whether you know programming, should be able to see what's going on just by reading this. Visit the sign-in page with a valid user, sign in. Be on the home page. Expect that the current user is the one that we expect. What this allows us to have is any changes to any of these implementation details get to happen in the page object instead of in the test. So you don't have to find the 30 places that you reference the drop-down, and now that it's a checkbox, it can all get put in the same place. So data management. This is writing autonomous tests. 3 different ways of approaching data management. First, I like to call grab and hope. This is take the first thing on the page and use it and hope no other test is doing something with it at the same time that will cause my test to fail. It is somewhat surprising how often you'll see flaky tests come as a result of when this test happens to run at the same time as this other test, it will fail, but when it's run on its own, it passes. A good autonomous test could be run by itself. It could be run in any order with any other test, and it can be run at the same time as any other test. The second main approach is what I call a fixture. This is often what developers like to do because that's what they're used to with unit tests. This is, let's populate a database with known values and then hard code what we're going to use in our tests against what we've put in the database. Oftentimes, manual testers that are used to working with a staging environment, automated testers will find existing data in the staging environment and then specify different specific values rather than just grabbing the first one, like let's grab the one that is this particular product, or let's grab one that's this particular user. These are difficult to scale because you have to hard code everything and you have to keep track of what are we doing with this user again? We're using this, oh, okay, so we need to add another user that has this parameter in order for these other tests. Recommended approach is what I call just-in-time. What this is every single test is responsible for all of the data that it needs to be successful. It needs a user, create that user for that test. It needs an address, create the address for that test. And then test editing it. Yes, this is slower. It takes more time to create that data for that given test. But we're trying to optimize maintenance costs and reliability, not execution time. I am totally on board with increasing how long it takes something to run if I am much more confident that with this entire approach, that a test is not going to fail as a result of a data problem. And especially when you're running in parallel, this is a big issue. And the third thing in atomic, autonomous, and short is writing shorter tests. This is data from our users at Sauce Labs. Tests are 2 times as likely to fail if they're over 7 minutes than if they're under 2 minutes. And I've definitely seen tests that run. I've had people ask me if they can, we have a hard limit at 5 hours for a test. And I've had people say, can we extend this, please? And it's like, you're not, let me help you. Let me help you. When is good for me to come on site and visit so we can address this approach? All right, so now into the fun stuff, a test framework. I define a framework. It's a very overloaded term. A lot of people use it to mean a lot of different things. I like to be very broad in my definition. The framework is the entire collection of code that you're using, from test runner to data management to helper libraries. The reason I like to define it very broadly is because that means that everyone is going to have some things that their framework does better than others. And so when I give ideas for how to address specific problems in the code, there's some things like, oh yeah, we're already doing that. But oh, this other thing, yes, we probably need to make that better. And someone else is going to have the exact same, the opposite problem of, oh, that first thing is what we're not doing well. And the entire purpose of a framework is going to be to reduce maintenance costs. And we'll talk about that. As an open source developer and proponent, I always encourage people to start trying to find something open source before they immediately start writing their own. Most people still write their own, but take a look at what's out there. See if you don't need to redo it from scratch just because other people's code is horrible and your code is awesome. Does everyone know what DRY stands for? Oh, you spoiled it. I was going to do that. That's all right. That's all right. Don't repeat yourself. Don't repeat yourself. That's great to a point. The idea behind don't repeat yourself is you should only have to make a change in one place anytime something needs to be changed. I don't always agree with that. 3 other acronyms, DAMP, remember what, descriptive and meaningful phrases. Especially with tests, it is much more important that it is clear and obvious what is going on and what you're testing than that you don't have any duplication. It's okay to have some duplication if it makes it more readable, more obvious what's going on. YAGNI, anyone know what YAGNI stands for? You ain't gonna need it. I've seen so many people jump into their test frameworks and just overcomplicate it from the beginning. I'm like, oh, we're probably going to want to use this for mobile next year, so let's create this entire global interface where we can do all of these things and make sure we can inject either this or this other thing, and then we'll set all of this other stuff up. Then what happens next year, you rewrite it all in JavaScript, and you never need, because you still didn't have the framework finished because you over-engineered it. Aha. This I think came from a Ruby talk. Avoid hasty abstractions. Actually see what needs to be optimized in your code before you start optimizing it. Once you see a pattern repeating, then abstract that out, rather than aha, I can never have a repeating pattern ever. We must abstract this out. That will complicate your code and make it more difficult to maintain. All right. So I list 7 different components of a test framework. I could probably give about an hour-long talk on each of these, given the chance, so I am just going to hit the highlights. We've already talked about writing tests and test data management. So let's jump into initialization and cleanup. The first thing when you're setting up a test is going to be creating the driver, creating your session, whatever that is. I'm always amused when I see this code being 1,000 lines long with a whole bunch of nested conditionals for every single piece of configuration information you might want. A lot of it's duplicated, and a lot of it's constants. One of my mentors like to tell me conditionals are bugs. If you think about conditionals as bugs, you're going to be a much better developer than if that's the first thing you're going to do every time you write code. I highly encourage people that if it is a constant, if it's not going to change, if there's no processing logic that has to go into it, prefer a lookup to a conditional. And so for testing, this would look like some kind of a YAML or a JSON where you would just put those values. And again, you'll see some duplication in some of these potentially. That's okay. Most likely, you're not going to be constantly changing what browser platform configuration you're running on. Especially with the browser version, this is Sauce Lab specific, but we support latest as a browser version option. And so if you've got latest up there, you probably aren't going to have to change this configuration file very often. And so just have a lookup that parses this file and creates what you want based on an environment variable or a system property or something that's happening from your CI tool. Okay. Oops. Got a little too aggressive on that. Page objects. I had a talk at SauceCon last year that was all about page objects, and I still didn't get through everything I wanted to talk about in that hour. I really enjoy page objects. I think they're a great way for how people think about the user interface, and it reduces a lot of the context shifting that needs to happen in order to properly abstract that out and work with it. There are some people that complain that page objects are too abstracted, and there are some people that complain that page objects are not abstracted enough. And for the most part, I think the approach can be done in a way that is just right. Now, a page object does not have to be a page. It can be an app view, it can be an entire page, it can be a header, a footer, a toolbar, a modal. But if you think about when something changes in the app that you have to adjust, when you write something new, you know exactly where that change is going to be made. So it's more obvious what you need to do in order to manage it. And a page object is essentially defining the elements and the actions that are needed on that page. So essentially, what services is that portion of the view providing for you? And if we think back to what I was saying about writing a declarative test, that means that we are abstracting out the data objects and the page objects, and all that the test is doing is saying, hey, on this page, log in. With this data object, give me this value. So you want to make sure that your page objects are the one that are listing step by step exactly what needs to happen for the provided functionality. APIs. So one of the advantages of the just-in-time testing approach is that if you have followed this just-in-time testing approach, where you're creating all of the data that your test needs when you're running the test, is you can speed that up. So you're like, oh, it's slower because you're having to travel through the site and fill out this form and fill out this other form and then navigate. It's still more reliable, that's still good. But what if you use an API instead? So essentially your API is the common gateway that your browser, your mobile device both interact with. So it's similar JSON blobs at specific endpoints. Why do you need to open a browser to use that API? Sometimes, sometimes not. One thing that I recommend people consider is authenticating with the REST client, getting the token, putting that token into the cookie, and adding that cookie to the site. So now you have one test that verifies you can log in, and then every other time that you have to log in to test something, you're avoiding that form. You're avoiding having to deal with that. You just get logged in. And oftentimes you have to work with your developers to make that happen. I have had a lot of success when I help my developers find problems and help them understand what's going on. When I ask for help from them for making the testing easier, I've had a lot of success getting that help from them, whether that's decreasing the message queue wait time so that my test doesn't have to wait that long in the staging environment, or finding a way to allow me to automatically log in the staging environment in a way that's not a security issue. So the goal is use a REST client to do these things. Create a new user with a REST client, create the address object with the REST client, and then do the editing in the UI. So for me, in an ideal test suite is going to be create an object in the UI, validate it in the API. Create the object in the API, validate that it's displayed correctly in the UI, create the object in the API, edit the object in the UI, validate with the API that it's been changed. So each of the tests is now only doing one thing in the browser where it's difficult, and everything else is managed by this API. All right, so now we get into the fun bit here, synchronization. The problem with the vast majority of frameworks where we are getting tests that fail, even though the system is working, is a result of synchronization issues. And there are 4 different ways to approach this. We have sleeps, which, as Simon says, never use. The only time I ever use a sleep is if I need to make sure that it's a timing, if there's something going on, is it a timing issue, throw in a sleep? Oh, that fixes it. What's going on here? Explore. Explicit waits is what everyone says to use. Talk about that. Implicit waits is what everyone says not to use. I kind of look at this, I've changed my thoughts on some of this a little bit as I'm looking at a lot of immature companies. If you have failures, a lot of failures, if you have more failures than you can keep up with, try turning on an implicit wait. An implicit wait, if you don't know, is where you delegate the responsibility for waiting for an element to show up to the driver. So instead of your code polling and asking, are you there yet, are you there yet, are you there yet, you're telling the driver, hey, don't come back with a response up until this time to find, don't time out for not finding an element up until 3 seconds or whatever it is. Try it out, don't put 30 seconds in there, try out just a little bit. My recommendation though, so in water, we had this define the element and we had a when present method. So we define the element dot when present dot click. And I'm like, as a tester, when am I ever going to want to click an element that's not present? This is kind of a ridiculous thing to put as a requirement into a framework that you have to specify this. I have seen a lot of code bases that have a lot of explicit waits that do the exact same thing every single time. Clutters the code, it makes it harder to read some of the things that are actually going on. When possible, I prefer a global solution that I refer to as an abstract weight. And it's going to look something like this. This is a very simplified approach. So have something in your base page or some implementation that you're making where when you take an action, it is going to do the synchronization before it takes that action. The advantage of this is you never have to wonder, I wonder if the element just wasn't there. It tried to find it. And I think that's one of the things that makes a good framework is to try and be a little bit more do what I mean instead of do what I say. Like I've said, click this. My test is deterministic. I know exactly what needs to happen for this test. Do the action. And then the framework should do its best to accomplish that task. So the water code for implementing this is much longer than this. We're checking for visibility. We're checking for a lot of different things. Now, when I implemented this in water, someone came to me and said, hey, your water tests are really slow on Sauce Labs. And I'm like, well, yeah, it's slower. It's making sure the synchronization, we're optimizing for reliability and maintenance rather than execution time. He's like, but it's really slow. I'm like, all right, fine. So I go and run a side-by-side, the same code in water and in Selenium, and I'm like, oh my gosh, water is so much slower. So water's making all these wire calls. Are you there yet? Is the browser window in the list of window handles? Is there an alert on the page? Are we in the default frame context? So the more advanced version of this is to what I call ask for forgiveness instead of asking for permission. Locate the element, click it. Selenium's going to tell you if there's a problem with that. Oh, look, element not found. OK, now wait for the element to show up and then retry. Or element not clickable. Do whatever processing makes sense for your context, for whether there might be something over it or something that is just going to be a transitory thing before you actually accomplish it. All right. So, in summary, don't overcomplicate things. If you're adding complexity, if you're adding conditionals, if you're adding extra logic, if you're adding additional abstraction layers, you should think about justifying it to yourself. Is this really what I need to do in order for this to work? You're optimizing for maintenance costs, not for execution costs or creation costs. Spend a little bit more time in what you're writing to make sure that it's something that you can maintain. I'll share this story as well. I had a company that asked me if I could help them reduce their overall testing time from 9 hours to 6 hours. I'm like, yeah, sure, absolutely, I could do that. We've got all these ideas, we'll figure out how to make that happen. I'm like, but let me ask you a couple questions. You're running these every night? They're like, yes. I'm like, so your employees aren't staying home longer than 6 hours? Like, why do you need it in 6 hours instead of 9 hours if you're running it overnight? You're still going to be processing the results in the morning either way. And I'm like, well, let me ask another question. What % failure rate do you have? They said 70%. I'm like, I asked for failure rate, not pass rate. And they're like, yeah, 70%. I'm like, I am not going to help you reduce your test time from 9 hours to 6 hours because there's zero need for me to deliver for you to have completely useless results 3 hours faster. Let's figure out what we need to do to get your test reliable, and then we'll figure out if that might include increasing parallelization or doing some additional abstraction, and maybe that'll result in some performance improvements on their own, but we need to first and foremost focus on actually getting useful results in a way that can be maintained. Because the whole point is reliably accurate tests that give a thumbs up or thumbs down to the developers for the code that they have written. Thank you for your time. Does anyone have any questions for me? Yes.
Wait.
Do we need a mic? Oh, we got a microphone runner. I won't get ahead of myself. Thank you.
Thank you for these pointers. A question, like you mentioned that sometimes you would say, like, no, I'm not going to help you, you need to do that and that. How do usually clients react to these things, and how do you mitigate stubbornness when they don't want to go your way?
No, that's an excellent point. You never want to tell someone that their baby is ugly. That's essentially what you're saying, yes. There's a lot of, like one of the approaches that I've learned to take is to compliment something that they're doing well, point out something, and I try, like you'll see here at the beginning of this talk, I'm like, I'm not telling you what to do and not to do, I'm giving you ideas for what you might be able to take home and think about in the future. It's all very, sometimes people, there are people that do really stupid things and believe wholeheartedly that that is the best thing to do. I'm not going to tell them they can't do that. I will try and focus on something that they are open to receiving, because they'll find out themselves in 6 months that what they're doing is not the right answer. I'm not sure if that completely answered your question, but examples of what? Yeah. No, yeah. I mean, you have to meet people where they are. Like like you can't. Sometimes it's a matter of the people I'm working with. It's their managers that are the problem. And so I've gone into a client before, and they're like, we're supposed to do continuous delivery. And like, all right, so let's start walking through this. And I'm like, oh, well, you can't do CD because you're reliant on this service, external service being up, and it's only up half an hour a day or whatever. And so we essentially made a list of 10 things that were keeping them from doing their job. And I went to the manager. I'm like, your team's amazing. They're doing a lot of great things under the restrictions they have. Here's the 10 things that they need to actually be able to do their job better. And the managers loved it. And the people that I was working with, they just needed someone external to them to tell their boss, these are the things that need to happen. And now they've got something that like, this person from, the smart person over here from the industry, in quotes, smart, said that these are the things we need to do. So something like that where you can get some kind of external validation, I know it's frustrating. I've left jobs before when like they were being very resistant to, like, this is a really bad way to do this. Like, we're not going to change. I'm like, all right, it's been a year. Yeah, I've been at Sauce Labs for a little over 3 years now. It's, I think, the longest tech job I've had, and so far really enjoying it. My boss is sitting right here. All right, who else had a question? I saw a few more hands.
The example you provided with an abstract weight was really funny to me, because this is exactly the way I do weights in my project. Mm-hmm. But at the core, this is really an explicit weight, right? Because
it's what?
But it is an explicit weight, right?
Yes, absolutely. It's a global explicit weight. Mm-hmm. So yeah, sorry for not explaining that better. So.
But my question is, you suggested to avoid it because you provided an example where the tests were running like 5 or 6 hours prior to that. So are you assuming that we should try to access the element without weight, and if then we have problems, then we...
No, yeah. No, like I'm mixing a couple different things here when I was talking about it then. Running a 5-hour test means that you're running all of your tests in one session. And we're like, no, you want to try and have this test is testing the edit feature, this test is testing the delete feature, this test is testing the whatever. And so you have, all of your tests should be under 2 minutes at most. In order to have reliable results, you have to have some kind of synchronization. And so rather than offloading that to the driver in an implicit weight, you want to have an explicit polling, but done globally so that you don't have to write it everywhere in your code, is what I meant by that.
Yeah. So did I get it right? Would you recommend for us to use implicit weight, like to try it, and if it works pretty well, so we should stick to it?
So one of the issues with implicit weights, the issues I have with implicit weights include, it makes some things more difficult to debug, it makes trying to find if something's not there more difficult, and it works oddly with explicit weights. So implicit weights by themselves aren't enough. And so if you have an implicit weight set and you're doing an explicit weight, weird things can happen, and it makes it difficult to see exactly what's going on when you're trying to find a problem in that specific thing. So if you're having problems, try running it with an implicit weight, see if it makes it better, figure out why it makes it better, and then remove it again. Is kind of the approach that I would take. But that's only if, like, I see that as like a short-term thing as you're trying to get more mature in your testing suite.
Thank you.
Yeah.
Other questions?
Hello, thank you for your speech. The question about the abstract whether I'm not sure if it can be usable where it says for bad performance solution when you cannot click element because you still try to load up.
Can you say that again?
So what sort of approach maybe you're going to take for bad performance kind of solution that performing back when you wait for element, you say you want to click element, but you still try to load up in the background?
Right. So what I was saying to do is, like, so for instance, and I've seen people's code where it's like, oh, this is a really smart approach implemented in a really bad way. And you'll see people like checking if there's an alert, if there's a window, if the frame, it'll do that. And then it'll iterate over that. So it'll do that before it checks if it's there. And then it'll do that again before it checks if it's visible. And so you can have like 20 wire calls where you really only need 2. So that's the performance that I'm kind of talking about with the ask for forgiveness instead of ask for permission. Just take the action, see what error comes back, and then address that error. So if there's no error, if it's there, if it's ready to be used, you can use it, 1 wire call. And if it's not, then you make the extra wire calls to make sure that the state of your browser is synchronized with where your code is at. Does that make sense as far as?
Not really.
Okay. Good. Talk to me after. We can talk
cool.
more.
Yeah, thank you.
I've got other slides I can show if you want to see.
Yeah, one more in detail.
I have like 500 slides that I try and pick between for these talks. Anyone else? I'll be up here as well if we want to talk after.
Okay, thank you very much for interesting and usable speech.
Great.
It was very good.
Thank you all for your time.